Alright, before we actually get into doing some examples, we need to look at two very special triangles that you would have learned about in geometry. One is a 45-45-90 triangle that's on the left. Notice since it's 45 it's isosceles, and so the two legs would both be 1. If you do Pythagorean theorem, you get the hypotenuse to be square root of 2. In a 30-60-90 triangle, we can basically drop an altitude on a equilateral triangle where all the angles are 60 degrees to give us the triangle on the left part of that equilateral triangle where the base would be 1, the hypotenuse is 2, and again using Pythagorean theorem that gives us square root of 3 for the height. So you can see I've written down the sine, cosine, tangent of 45 degrees and 30 degrees, and you can partially see the 60 degrees. I'm going to move it up just a touch so you can see the tangent of 60 degrees. But all this is just using the information we have from those triangles. So if I'm looking at the sine of 30 degrees, sine I know from SOHCAHTOA is opposite over hypotenuse. So that's going to give me 1 over 2, and you can figure those all out. These should be things that are memorized. You should not need a calculator for this. If you have questions like this on a test, I'd much rather see exact values than what you would get if you plug this into a calculator. Also, if I gave you radian measurements of these things, if I asked for the tangent of pi over 6, well, pi over 6 is the same as 30 degrees, and so you should know that that answer is square root of 3 over 3. So these are the types of things that you should know these triangles already and should be able to apply them whether I give you an angle in degrees or radians, as long as it's one of these basic ones.